I'd like to take a few minutes now to go over how you might solve a simple pedigree problem. In this question you have the particular situation here where the unaffected parents having an unaffected daughter and an affected daughter. And the question is, what is the most likely mode of inheritance? And the best way to solve these problems is to take all the possibilities and work them through one by one and see which ones are consistent and which ones aren't. The first we'll consider is autosomal recessive. In that case, you define some alleles like this. Big D would be normal, and it would be dominant. Little d would be disease, and it would be recessive. And then you start by working through each member of the pedigree, first just based on their phenotype, not worrying about how they're related to one another. So let's start with the mother up here. Because she's normal, you know that she has to have at least one big D allele. You don't necessarily know what her other one is yet. Likewise, the father has at least one big D allele to be normal. This daughter has one big D allele to be normal. And to be affected, this daughter down here must be little d, little d. That's the only way you can be affected. So far, so good. The next step is where you really check to see if the model fits, and you do that by tracking down the individual alleles and where they came from. So you start here with the disease alleles that this daughter down here has, and ask where did she get her two little d's? And the answer is you can explain both of them. If she got one of her little d's from her mother, her mom would have to be big D, little d, and she got her other little d from her father, and her father would be big D, little d, and both of them can be unaffected carriers like this. And then finally, if you work out the last details, it is possible for two carrier parents to have an unaffected daughter. She would have at least one big D and one unknown allele. So this is consistent. It is possible that this disease is inherited in an autosomal recessive fashion. Now let's look at that same pedigree from the point of view of the next possible mode of inheritance. Let's try autosomal dominant. For this, we'll define symbols. Say big N will be disease, and it's dominant. And little n will make normal and recessive. Okay? And again, you go through these, working through based on their phenotypes. So if you take the unaffected individuals, like the parents and that sister, you know that the only way to be unaffected is to have two little n's, two normal alleles, because if you had one big N, you'd be affected. So these guys would be little n, little n. Likewise, this daughter down here must be big N, and we don't know what else, big N blank. And again, as we did last time, if you trace through the particular alleles and where they came from, you can find where they might have come from. So, for example, you can look at this daughter, and she got one of her little n's from her mother and got her other little n from her father. But then if you look at the other daughter, the affected daughter, you have a problem. And that is, where did this big N come from? Neither of her parents has a big N, for if they did, they would be affected. So in this case, this is not consistent. That is, one or more parents must be affected to have an affected child. And that's not the case here. So it cannot be autosomal dominant based on this bit of data here.